Welcome. Today we are going to discuss one interesting topic about philosophy of AI, and our topic is this. What are brain-computer interfaces and how do they relate to AI and cognition? A brain-computer interface, BCI, is a direct communication pathway between the brain and the external device, typically a computer or a robotic system. Its primary goal is to enable the translation of neural activity into digital commands without the mediation of muscles or peripheral nerves. In essence, BCI's bypass of body's traditional motor outputs and connect cognitive processes directly to technological systems. From the standpoint of philosophy of mind and AI, this represents a profound step in the history of cognition. It operationalizes the idea that thought itself can become a form of computation. The development of BCIs relies heavily on artificial intelligence techniques, especially in signal processing and pattern recognition. The brain generates complex electrical activity that is recorded using methods such as EEG, ECOG, or fMRI. These raw neural signals are noisy, multi-dimensional, and ambiguous. AI algorithms, particularly machine learning models, are employed to interpret this data, identifying patterns that correspond to cognitive states, intentions, or sensory perceptions. For instance, BCIs may learn to recognize specific neural signatures associated with a user's intent to move a cursor, speak a word, or control a robotic limb. This dependence on AI creates a reciprocal relationship between artificial and biological intelligence. On one hand, BCIs use AI to decode the mind's activity. On the other, they allow human cognition to extend itself through artificial systems. This resonates with Andrew Clark and David Chalmers' extended mind hypothesis, which argues that cognitive processes are not confined to the brain but can extend into the environment through tools, symbols, and technologies. In the case of BCIs, the extension is not merely metaphorical but literal. Neural signals merge with computational architectures, forming what some philosophers have termed a neurotechnological hybrid mind. From a cognitive standpoint, BCIs challenge traditional conceptions of agency, selfhood, and embodiment. If AI systems can anticipate or interpret neural commands, the line between who acts and what acts becomes ambiguous. Philosophically, this raises questions akin to those found in debates over distributed cognition and cyborg epistemology. Does cognitive enhancements through AI create a new form of shared intelligence between human and mind? Or does it merely amplify the computational side of thought at the expense of its phenomenological depth? Scholars such as Catherine Heislis have argued that such integration risk reducing the richness of embodied consciousness to digital information, whereas others see in BCIs a new horizon of co-evolution between biological and artificial cognition. The relationship between BCIs and AI is therefore mutually constitutive. BCIs depend on AI to make sense of neural information, while AI increasingly draws inspiration from the function of the human brain, an epistemic feedback loop that blurs the boundary between model and modeled. This relationship situates BCIs at the intersection of two great philosophical inquiries: the nature of mind, as explored in cognitive science and phenomenology, and the nature of artificial agency, as investigated in AI ethics and philosophy of technology. Ultimately, BCIs provide not only a technological bridge between brain and computer, but also a philosophical bridge between neural and artificial intelligence. They invite us to reconsider cognition, not as a static property of an organism, but as a dynamic network of informational processes that may one day operate seamlessly across organic and artificial substrates. Okay, that's all for today's discussion. Thank you for watching. If you have got any questions, you can address them in the below. Thank you.